You're welcome in your maths, and I got a new problem. Today we are going to prove this.
So for proving this, let's understand the concept. Let's say we have a number a and we can write its prime factorization as x into y into z. Let's suppose now these all are the factors of a, its prime factorization. Okay, and x square it's also a factor, means if we multiply two prime factors then we get a new factor of a. That's it. Now let's start proving this. So we have a number a which is in the form of x into y into z, and let's say we have a number b which is in the form of x into y into m into n. Now we have to talk about its HCF. So HCF is what? Highest common factor. And now let's talk about highest factor. So x and x square, which one is the highest factor of a? So x square. But in the HCF we have highest common factor, means we have to take common factor. So here first of all x is common, but I can't stop here. We have to multiply much more number if it's possible. So here y is also common, so we can write x into y is the HCF of a and b. As I have told you, two prime factors gives the factor of any number. In common it's the highest factor here. Now let's talk about LCM, which is lowest common multiple, which means I need multiple of a and b, but it must be lowest and common. So this is the prime factorization of a, and if we multiply this we get a, and if we multiply any other number then we get the multiple of a. Therefore you can see that you have to multiply all prime factors of a and b to get the LCM of a and b. But you want lowest, so you can exclude the double repetition of common prime factor of a and b. You can write only x into y instead of x into y two times. Remember, in the LCM you need to multiply all prime factors, so I have to multiply also all remaining prime factors as well. So x into y into z into m into n, the remaining prime factors of both numbers. As you can see, it's divisible by a and b as well, and it's the lowest common multiple. Now you can see that in the case of HCF I have multiplied the common prime factor of a and b, and in the LCM I have multiplied one time the common prime factor of a and b and the remaining factors as well of a and b. Now as you can see, in the HCF we have one time common prime factor, and in the LCM we have one time common prime factor. That means we have all total common prime factors and the remaining factors. That means we have multiplied all the prime factors of a and b. It means it's a into b, and you have proved that HCF into LCM is product of two numbers. Hopefully you get it, so don't forget to like and subscribe.